Alright, we're going to make a rocket in Fusion. So, first things first, save this thing, right, so that it saves. So you save it wherever you want to save it. Me, I've got little folders set up. I've actually already done this once, but I'm going to do it again. Whoop. 2. Mechanical keyboard. Love that clickety clack. Okay, first things first, you've done a drawing, you should have scanned it and saved it as an image. And what we're going to do is we are going to chuck that into our work environment here in Fusion. So we're going to go to Insert and lock up the whole thing. This computer is very expensive. This is frustrating. And we're going to insert a canvas. Now, you're going to have that saved somewhere in your computer. And we are going to go to wherever the heck that is. And it'll ask you, where do you want to put that? Now, I'm going to put that on this face here because that makes the most sense to me. And we're just going to click OK. Right, and zoom in on that and bring it to the front. Whoa, so we've got to do some fixing here. So the first thing I'm going to do is just make this nice and level. So I'm going to move it and let's just right click on this. Whoa. I got rid of that there for a second. Let's go canvas, and what can we do with this? We can edit the canvas. Beautiful. If we can edit the canvas, what we can do is we can swivel it a little bit. So let's just move it. Clearly 1 degree is too much. What if we move it 2 degrees? That's not bad. That'll do. That's pretty level. Pretty level, pretty level. It'll do. Anyway, and then what we need to do is we need to scale that. So we are going to go calibrate. And conveniently, I know that from the back of my rocket to the front of my rocket, or this bounding box, is 100 millimeters. So what I can do is I can click the back and the front, and I can then type in my dimension in millimeters, and there is my drawing, and it is scaled. Sweet. So now that we've got that there, we can start putting our sketch over the top of it. So go to Create Sketch, and we're going to create it on this plane. And what I would do from here is I would put a rectangle around this thing. So I'm going to choose a construction line, and just like we have a bounding box here on our pencil drawing, we're going to have a bounding box here in our sketch. So just from corner, and make sure that that is 100 by 100, because this is actually going to define the physical dimensions of our part, and the maximum size it can be is 100 by 100. So you need that. And then from here, I'm going to lay out a center line because this is a symmetrical object. And so being a symmetrical object, it makes it nice and easy to make it if I have a center line. So I'm just going to draw this center line and make sure that it is 90 degrees to the edge of your bounding box here. And you can see we've got angle there. When we move it to 90 degrees, or rather this one's measuring 180 degrees, we can see a couple of things. We can see that we've got 180 degrees at the top, and we can see a little square in the edge. So we can click and know that that is perpendicular. That's the word I'm looking for. If you want to make it perpendicular, what you can also do is you can go to one of these little constraints, and you could actually fix that if it wasn't perpendicular. Let's draw one that's not perpendicular, just for fun. Here's a line. All right, that's there. Clearly not perpendicular, not even close to perpendicular. Come up here to your constraints, perpendicular. And we're going to go this line, make it perpendicular with this line. And that will snap it to perpendicular. Next thing we're going to do is dimension that line. So for me, I know that this was 40 millimeters. And so I know that I really want this line here to be 20 millimeters from the top of this. So I click my line, and then I click what I want to measure off. I put in 20. And from here, I'm going to start actually doing some solid lines. And I'm going to use the fit point spline, which is a tool that you maybe haven't used before. So fit point spline, I'm I'm going to turn off construction, and I'm going to start from here. Now, just before I do that, one thing that might be worth doing is I'm just going to hit escape. I'm going to go back to this rocket scale drawing. And what I'm going to do is I'm just going to see if I can turn down the opacity. And what does this say? There we go. So I can just turn down the opacity just a little bit. Makes it easier to see my actual sketch dimensions. Cool. Back to lines. So fit point spline. So the fit point spline is pretty simple. You click once, and then every time you click from here, you lay down what you would call a fit point. And I'm just going to sort of follow my rocket, but also you don't have to be completely bound by your underlying drawing. If you think that smoothing out some of these lines or doing some stuff like that makes it look better, then by all means do that. All right, so hit escape. So with these splines, you can click them and you can move them, which will change the shape. So I'm just going to move these just a little bit so that I get a slightly smoother sort of set of arcs through my design, because I think that looks nice. Yeah, that'll do. And once I'm happy with that, I can click this line. And because my design's symmetrical and I have this center line, I can use the mirror tool. Right, I've already got this line selected, so I select my mirror line, and I get one down the bottom. Cool. And then I can choose my line, and I can close that shape, and see how it changes color? Now I can click on it, and I can extrude it up and do all sorts of things with it. Right, so that's a good place to start. Now from here, I'm going to draw some fins in, and to do the fins, I am going to use first an arc tool, and I'm going to use a 3-point arc. What a 3-point arc lets you do is it lets you go one, so you get to go start, finish, and then you can choose your arc. Right, and if I zoom in, I get a little bit more control. Right, there's my arc. And then you could use an arc to finish this. That actually looks pretty good. I was going to say, I don't like the arc. I'd much rather use a fit point spline, but that actually looks pretty decent. If you wanted to use a fit point spline, of course you could. You could just go like that. Right, and there you go. Now, notice something important here. This is not blue. I can't extrude this. I can't grab it. I can't click on it. And there is a reason for that. And the reason is, this is not joined on, so it hasn't made a solid shape. So if that's the case, right, you got to close this before it will behave itself. And so you can grab these and you can drag them around, and that's what I just did there. So once you close a piece of geometry, and that's what that means, you close a piece of geometry, there's no gaps, then you can select it and you can do stuff with it, like extrude it up. Cool, so once again, symmetrical design, mirror line, mirror that out. There we go. Cool, and then let's throw this window in there. And again, symmetrical design makes it real easy. 20 mil, there we go. And I can dimension that off the front of my rocket. And I am really passionate about having intentional numbers on things. Just designing things to be like an actual dimension, not just putting things in random spots. So I will dimension pretty much everything I do, even if I'm doing something that's more of an artistic kind of project. I've still got just dimensions on everything to make them nice numbers that are actually intentional rather than just random stuff. I'm not going to draw this little face in here just at the moment, and I'm going to move on with the rest of the rocket, and then I'll sort of show you why that is. Now, what I know from my drawing and my planning that this is supposed to be 50 millimeters from this back edge. And there's a couple of different ways I can do that. I can just draw a circle. And that circle I know needs to be 4.2 millimeters. And I can dimension that off this edge line, pretty close, and make that 50 millimeters. Right. The other thing that I can do is I can make a construction line. So, by the way, pressing X will toggle construction lines on and off. It's pretty handy. And I can find the center of this 100 millimeter line. When I get to the center, I get this triangle symbol. So that tells me I'm in the center. Right, so then I can lay a center line out, turn my construction lines off, and put in that 4.2 millimeter circle again. Now again, intentional numbers, not just random stuff. So I'm actually going to dimension that off the center line of my rocket. See, it's close. It's close to being a nice intentional number, but it's not quite. So I'm going to make that 40 millimeters and then come in and make this, I think I wanted this to be 8 millimeters. Right, I don't want this to be too small, right? The rim of this hole, for example. I don't want that to be too small because it'll be weak, but you know, this is probably plenty. I could make it more bigger if I wanted to. In fact, maybe I will. As I'm talking, let's make it 10. And then from here, line. And with this, you're going to struggle to get a line right off this nice edge. To, you know, like if I lay a line out, right, it's not quite at the edge. A couple different ways that you can sort of get around that. So for a start, this line here is parallel to this line here. So if I move this line, it's always going to stay parallel to this guideline. Right, and so what I can do is I can use the tangent constraint, and I can say, hey, this line, which is locked into being parallel with this line, I want it to meet this circle at that sort of tangent point. Now that's moved everything, which is 100% not what I wanted. So there is a way to fix that. What we do is we just grab one of these and we lock it down. We just click fix. And they go solid black, and it means they don't move. And so this time, if I click on this, it will move that line. Right, so that's one way to do that. Right, I'm going to Control Z a little bit. And let's just delete that line. Right, the other way to do it is we can lay guidelines out. So if I go from the center of the circle out to the edge, I get that nice perpendicular constraint, or 9 degree, and then I can run up from that point up here. I can make sure, well, let's not even make sure it's parallel. Let's just put it on a wonk angle, and then we can take the parallel constraint and apply it to that line. Cool. And I can mirror that from there. Oop, that's not what I'm trying to mirror. I'm trying to use that as the mirror line. There we go. And of course that doesn't actually join because it's not, this is not the same. This is not uniform. Or not uniform is the wrong word. Whatever word I'm looking for. So let's just do it by hand instead. So again, we can't find that point. Constraint. Let's just draw a line out to that edge. And then we can get it on that point, run it up there. Let's put it on a wonk angle again, just to use that parallel constraint. Cool. And now let's extrude things up. So remembering that everything's got to be flat on the base, right? So if we're going to get depth and, you know, this illusion that things are, you know, at different points, we're going to have to do it while keeping everything flat. So this first thing, I'm going to bring it up 10 mil, and then my sketch is going to disappear. What a crisis. Come over here to the drop-down menu on the left and just unhide that sketch by clicking on the eye. It brings everything back. And then grab the fins, and the fins can come up 5 mil, and so can this thing, right? 5 millimeters. And then this circle, by the way, I'm hitting E instead of going to solid and clicking that. I'm just pressing the E key. This can come out 10 millimeters. Cool. And pretty happy with that. Now, what I'm going to do from here is actually make another sketch to do my little, you know, Eldritch Horror, whatever, space face dude. So make sure that if you're making more sketches, you're putting them where you want to put them. So I can see here, and I'm just moving the sort of work environment around. You know, I can see I'm highlighting that surface. That's where I'm going to draw my face. Now, it might move the thing, which is a little frustrating. It's just moving it down to the origin, right? But we can just move back up. So, Eldritch Horror. Let's go and go in with our fit point spline. Now, here's what's going to happen. I cannot snap to this circle because this circle is not part of this sketch. So what I use is I use the project tool. Now you can find that in the sketch menu under project include. You can also just hit P on your keyboard. And what project lets you do is it lets you select things that you can bring into any sketch you're working on. So see here, I can click this circle. Okay. And let me just hide the body real quick and hide the canvas real quick. See how now there's a circle in this sketch we're working on. I'll hide the sketch too, sorry. Right, so I'm gonna draw my little Eldritch Horror in this sketch, and it's gonna have this circle there, and everything's gonna be good and dandy. So bring my canvas back. And fit point spline, and off we go. And notice that I'm sort of taking liberties with this underlying drawing, right? The underlying drawing is there to help me, but it's not something I need to follow absolutely religiously. The other thing that's worth noting about the fit point spline is that if you try and do a sharp angle on it, it'll just feed you curves, right? So it's not great. If you want to get sharp angles on it, you're much better off finishing one sort of spline by double clicking, right? And then go from the next point. Right. Oop. And what this lets you do is get those nice sharp edges if you want sharp edges. Oop. Stuff that last one up. Let's just come back in there. And by all means, zoom in. You know, manipulate your work environment to make your life easy. Don't make your life hard. Whoop. Stuff that one too. I'll be honest with you folks. I very rarely use the fit point spline. It's not like my tool of choice for things. All right, cool. There's my shapes. Now, do I have an enclosed shape? Yeah, it turns blue. Good. So that's enclosed. And then to put this sort of detail in here, I'm just going to do a circle. And details. You don't want to go sort of smaller than 2 mil on any particular detail. You go smaller than 2 mil on a detail, the printers might have a hard time resolving it, right? So I'm going to go 2.5. That's kind of big and goofy looking, isn't it? Let's see what happens when we put a line in it. Let's just have a look. And grab that. And grab that. And we'll extrude that up. I'm just going to extrude that up 3 mil. And how does that look? I don't like that at all. Yeah, don't like that at all. So let's just get rid of that. And I'm going to put it somewhere completely different. I'm going to see if that changes sort of the feel of the thing. More like a, you know, an eye in the middle. Let's try that. See what that looks like. Now it kind of looks like a goofy man in the moon. So I like that even less. Alright. Whatever. Eye where the eye is. Maybe we'll put it further out. And we'll just make it 2 mil. 2 mil. Put a line here. Extrude this out 3 millimeters. Yeah, I'm happy enough with that. Cool. So let's just have a look at that all as one. Yeah, that I can go with. All right. So I'm just going to hide my canvas for a second. And I'm just going to show you an easy way to add just a little bit more sort of detail to make this look a little bit more interesting. So I want another sketch on this surface. Of course, it moves back there, but just move back where it is. So I'm just going to put like a little rim, like a little outline on this using this tool, which is the offset tool. And what offset lets you do is grab a line and you can drag something off it. Now, I know I said don't make a detail smaller than 2 millimeters, but this is the exception. Because of the way a 3D printer works, if you have sort of something on the edges like this, you can make that any multiple of the nozzle thickness. Now, if that doesn't mean anything to you, what that means is, right, the nozzle squeezes out plastic at a certain thickness between 0.4 on our finer printers and 0.6 on our thicker printers, which means if you make this line, say, a nice multiple of both 0.4 and 0.6, like, say, it's 1.2, except in the negative direction, right? Then the printer will just run, if it's a 0.4 nozzle, it'll run 3 lines around here. If it's a 0.6, it'll run 2, and it'll resolve that detail really nicely. So I'm going to do one there, again, 1.2, 1.2, and then I'm just going to extrude those up. And I can extrude those up by a really small amount. We're talking layer heights here, so like 0.4, right? 0.5, 0.4, 0.6, whatever you like. And it's just going to add that little bit of like visual interest. It's going to make it look a whole lot better. You could do the same thing with the fins if you want. You could add more details to this if you wanted to. You could put little circles on here and like extrude up little bolts. With little details like that, you do want to obey the nothing smaller than 2mm rule. But you can do all sorts of things with that. And that is your design. Make sure you check it, right? Have a look at it from all angles. It should be dead flat on the base, right? Because that's where it's going to stick down to print. And we can't have it, we don't want any overhangs. We just want it to sit flat on the bed while that gets printed, right? So from there, looks kind of jank. From there, I don't think it looks half bad. Right, now, make sure you save that. Stop doing that. All right, make sure you save it. And then from here, you are going to need to export that file for printing. So come in here to where it says body, and you are going to right click on that body. And you're going to come down here to the option that says save as mesh, and you're going to click on that. Now you might need to change some options. We are going to use STL binary, and we're going to, this should say millimeters, but if it doesn't, flick it to millimeters, and that should be it, right? You don't have to mess with anything else, just STL binary, make sure it's millimeter, click OK. And what this will do is it will ask you where to save it. So please make sure you click on this, right? And put this somewhere logical, right? I'm going to put it here. And you can name it something sensible. So when you name things, I want them to be named your name, so me, right? And then what it is, still not entirely sure what we're calling this project, so let's just call it tilt project piece. And then depending on what you're printing, you might get to say, hey, I want it to be this color, I want it to be that color, or whatever. At the moment, you're not getting a choice. We'll run some colors and you get to pick from that. So whatever color we tell you is on offer, you pick one of those. So I'm going to say like lilac. I don't know if that's how you spell lilac, and I don't really care. Cool. And then you're going to save that. And that's the file that you will then go on to slice up and to print in the 3D printer. Cool. I think that's everything. That's how to design the thing.